All right, Algebra Kids, here is your recap on scientific notation, section 8.4. Remember, this is not the full lesson, the best lesson, the most amazing thing ever. This is just a little refresher on things that perhaps you have forgotten about from class, something to help you if you need little homework help. It does not fully replace attendance or attentiveness in class. So we are studying scientific notation, which is something that we use to write extremely large or small numbers more concisely so that we can represent them in things like textbooks, also so we can work with them a little bit easier when we're doing other operations like addition, subtraction, multiplication, and division. And so I have the format for you here. Basically what this means is number in scientific notation is going to start with just one digit between 1 and 9, so for example like this, and it is going to be followed immediately by a decimal point and then any of the remaining digits until it just gets to zeros. So like for example this one digit followed by a decimal and then all the other digits until you get to just zeros. We always use the multiplication x, never the multiplication dot. Then times 10, we use base 10 number system, so it's always going to be 10, never anything different. And then the exponent will be small and raised. This can be positive or negative. This is sometimes confusing because we just came off of the negative exponents lesson. It is okay to have a negative exponent when you're working with scientific notation. Just keep in mind that if you have a positive exponent, expect to have a number larger than 1, and if you have a negative exponent, you will have a decimal. In general, if you also have a positive exponent and you are converting to standard form or the normal form of a number, you will move that decimal place to the right. If it's a negative exponent, you move to the left. And so this is one of those things just where practice makes perfect. These rules will eventually all mesh together and click, and you will be moving along like a scientific standard form writing rock star, if that is such a thing. So yeah, let's practice a few. So this number is 2.834 times 10 squared. Now what it means is this. It means 2.834 times 10 squared is 100. Now think about this. If I multiplied 2 almost 3 by 100, I would get about 300, wouldn't I? Right? Okay. Well, I have a positive exponent of 2. So I'm going to move my decimal place to the right to make my number into a large number, like 283. So I'm moving 1, 2 places to the right. So 283.4. Now, if you need to use a calculator to check yourself, obviously we don't want to depend on a calculator, but you can use it to check yourself while you are getting accustomed to this. Just know that if you have an exponent that's like 9 or 10, your calculator cannot handle all of that. Okay, so now I have a negative exponent, so I'm going to expect that my number in standard form is going to be a decimal. And because then I have a negative exponent, I'm going to move my decimal from scientific notation to the left. That makes sense because I'm going to be making it smaller. So I'm starting with 1.23. I'm going to move 6 places to the left. So 1, 2, 3, 4, 5, 6. All of these little swoopies, I think that's the technical term, indicate a place where I'm going to fill that placeholder with a 0. Now once I've done that, I'm going to put in the decimal place there, put the decimal there, and then use the placeholder 0 at the start. So my number in standard form will be, I believe there are 5 zeros there. Yep, good. Again, please make sure that you get that placeholder 0 in the front. Okay, moving in the opposite direction, let's write some numbers from standard form into scientific notation. So it's always going to be the first number followed by a decimal. Then all of the other numbers until you get to zeros. So I'm going to drop this last 0, but I still count that 0 when I am figuring what my exponent needs to be on the base 10. So 3.469 times 10. And see how I put my decimal between 3 and 4? I'm going to put my pen here between 3 and 4 and count to the end of the number, all the place values. 1, 2, 3, 4. And because this is a number larger than 1, I know that my exponent is going to be a positive 4. Let's try another one of these. I'm going to just focus on this part. All of these zeros can be dropped when I write my beginning of scientific notation. Now this 0 needs to stay there, the one between the 6 and the 2. That's a placeholder for a multiple of 10. But all of these can be dropped. We're still going to consider them though when we find our exponent that goes on the 10. So my decimal is between 6 and 0. So I'm going to put my pen between 6 and 0 and count the place values to the end of the number. So 1, 2, 3, 4, 5, 6, 7, 8. Because this is a large number, I know that this is going to be a positive 8. Now, one subtle rule to keep in mind, I told you to drop all of the zeros at the end. So you may feel compelled here to write 10 or 7 times 10 to the 3, 6, 9, 12th. That is the correct value. However, to indicate that 7 is followed by only zeros, in this one small case, you would write 7.0 times 10 to the 12th. All right, see if you can write this last one in scientific notation successfully. So I'm going to start with 7.22. I'm skipping all of these, right? My decimal is, hi Mini Cat. My cat is joining me. I'm going to put the decimal between 7 and 2 because it's 1-digit decimal and all the other non-zero digits here. So I'm going to put my pen over here and count how many place values to the decimal. So 1, 2, 3, 4. And because I have a decimal here, I know that my exponent is going to be a -4. All right, again, practice, practice, practice. That's why we have homework. I don't just assign homework to make my students miserable, while I do secretly get a kick out of that. Oh, no, just kidding. It is for your ultimate good so that you can practice these things. So, all right, let's talk about multiplication with scientific notation, if I can find that in my notes. Okay, so the beautiful thing about multiplication is that you do not necessarily have to multiply expressions in the order that they're written. So here we have, in scientific notation, 1.4 times 10 to the 4th. Here, same thing. Now, you could say that this is just 1.4 times 10 to the 4th times 7.6 times 10 cubed. Straight across, kind of like this, right? It means the exact same thing. Well, what you can do to make your lives a little bit easier is to combine these two base 10s, because you know that when you have the same base, you can keep that base and add the exponents. So 10 to the 4th times 10 cubed is 10 to the 7th, right? And now this part, these are taken care of. So all you really need to figure is the 1.4 times 7.6, these two, which is 10.64. Now this is the correct value, but once you have a solution, please make sure that you are in proper scientific notation, meaning 1 digit, then followed by a decimal. See how this has 2 digits? That's not okay. Now, if I'm moving from this 10 to a 1, that means I am decreasing by a power of 10. To compensate for that, then I must over here increase by a power of 10. Again, you may and you should check your work with a calculator if you're feeling a little anxious or insecure about what you're doing. So basically, just to summarize that, for multiplication with scientific notation, multiply the first numbers together, and then multiply the second numbers together, which are both base 10. So do times 10 and then add the exponents. Okay, division is very similar, where you just handle the first part together and then the base 10 parts together. So this would be 1.2 over 4.8, which is 0.25. I can already tell that I'm going to have to adjust that in a minute. Times 10 to the negative first over 10 to the negative fourth, same base, so we're going to do the top minus the bottom exponent, so -1 minus -4, -1 plus 4 is 3. Now I have to then adjust this 0.25 to 2.5, one digit followed by a decimal, and then the rest. And because I increased by multiple 10, then now I need to decrease by multiple 10. And so you can again check yourself on a calculator to make sure that that is in fact the case. Okay, take a second, pause this, try the bottom two, and then once you're ready, you can hit play again and I'll walk you through these sample questions. 4 times 3 is 12, times 10, same base, -2 and 6 is 4. This is the correct value, but not the correct, or most, not most best, not the most mature way to write this. So you would write a 1.2, and because I decrease by a multiple of 10, I will compensate by increasing by a multiple 10 on this side. All right, over here, we'll do 1.4 divided by 3.5 times 10 to the -1 minus -4. That's just like what we did up here. Is 10 cubed. And this is 0.4 times 10 cubed. Correct value, but not the correct form. So increase by a multiple of 10 and then decrease by a multiple of 10 to find your answer there. Okay, and now we have exponents in scientific notation. This is just the same as exponents with parentheses that we did before. Just remember that if you have an exponent on the outside of the parentheses, it distributes to everything within, and that includes scientific notation. So this means 4 cubed times 10 to the -2 power cubed. And you know, if you're distributing from outside parentheses, you'll multiply these exponents. 4 cubed is 64 times 10 to the -6. Correct value, but remember it's 6.4 times 10. Be careful because you're working with a negative exponent, so things can get a little bit squirrely. I just decreased by a multiple of 10, so now I need to increase by a multiple 10. But when you are working with a negative exponent, increasing from -6 is -5. Sometimes students think backwards when they're working with negatives. Okay, again, try this last question. Hit pause when you think you have a correct answer, then hit play again. And so you should have 3 to the 4th times 10 to the -8, because 4 times -2 is -8. 3 to the 4th is 81 times 10 to the -8. Correct value, but not the correct form. Reduce this by a multiple of 10, and then increase this by a multiple of 10 to compensate. And that is the final solution. All right, hopefully that was a good review for you. That's not a lot of practice with each type though, so you're gonna need to do your homework. And if you are not getting enough practice with the homework that is assigned, you should consider working through that redo. I know you may not want to, but you will be a whole lot more comfortable moving forward if you have a strong footing on this. And, you know, practice makes perfect, that's what they say. Or practice at least makes better or not so bad. Okay, So this is the homework side. I am going to do some samples from the redo side so I don't, inadvertently do your homework for you. Or also, if you've already done the homework and maybe it didn't go so hot and you want some practice with the redo side, I can talk you through some of these. Okay, for this top section, you're just rewriting in decimal form. So here I have, is this big enough? There you go. Here I have a positive exponent, so I can expect this number to be larger. I'm just going to write down this 379. The decimal was between 3 and 7, so I'll put my pen between 3 and 7. And now I need to go 5 places to the right to make this bigger by 5 multiples of 10. So 1, 2, 3, 4, 5. Can you hear me over the train? The train only goes by when I'm recording videos, I'm pretty sure. Actually, that's not true. The train goes by all the time. But I only notice when I'm taking a video. So anyway, that's what you do there. Let's try number 7. That's a different kind. So I'm just going to write 10056. I know this is going to be decimal, so I'm just going to scrunch it over to the right. Okay. So the decimal was between 1 and 0. I'm going to put my pen between 1 and 0. I need to go 5 places to the left to find where I'm going to put my decimal point. 1, 2, 3, 4, 5. Don't feel silly drawing these little swoops. People do it all the time. If it helps you be more accurate, then you go on ahead and do that. Once you put your decimal point in there, don't forget the placeholder 0. It's a little bit messy, but it's good enough for me. Okay. So that's writing in decimal form or standard form or normal form or whatever you want to call it. Okay, let's write some numbers in scientific notation. So this is a big number. It's going to have a positive exponent. When I write it, you want to keep this 0 because it's necessary for a placeholder. But these we're going to drop. So it's going to go 2.20786 times 10. To what power? I'm going to put my pen between 2 and 2 and count the place values all the way to the end of the number. So 1, 2, 3, 4, 5, 6, 7. And that's how that goes. Try the next one. Forget all this. 7.485 times 10. This is a decimal, so my exponent will be negative. My decimal is between 7 and 4. My pen is between 7 and 4. I'm going to travel to the left 1, 2, 3 places. So to the negative third. Okie doke. Let's do some multiplication and division here. Just like the end of that video. I'm going to run out of room. Oh yeah, this is the one where you write your answers at the bottom down here. That's going to make everybody dizzy if I do that. So, let's see if I can find some scratch paper on the fly. I'm just going to write mine to the side. And of course, I'm going to zoom. Whoa. Hope I'm not making you dizzy. Okay. All right, so if I have that's the problem. Do this first. 5 times 3 is 15. Times 10 to the, add the exponents. Negative 3 and 6 make 3. This is the correct value, but not the correct form. It becomes 1.5. I decreased, now increase by a power of 10. Okay. The instructions ask for you to write in both forms. So 1, 2, 3, 4. So 15,000. And that means the same thing. You would write that solution at the bottom of your page where there's room. Let's try one like 22. Sorry, that was 19, by the way. 22. Okay. 5 over 8 times 10 to the negative 2 times 10 to the negative 6 Oh, I had to memorize all my fractions in eighth grade. I think this is 0.675. Might want to check me. Times 10 to the negative 2 minus negative 6 is negative 2 plus 6, which is 4. I think that's right. I'm actually kind of impressed that I still remember that. Whew. That sounded really arrogant. Not what I intended. Anyway, so I need this to be the first digit, decimal, and then the rest. So I increase by a multiple of 10, so I will decrease by a multiple of 10 over here to compensate. And then write it in standard form. So I had 6.75, so here's 675. I need to move 3 place values to the right because this is a positive exponent. So 1, 2, 3. Bam. Okay, that was 22. You'd write that at the bottom. Okay, lastly, 25. 4 times 10 to the negative 4th, negative 1st. Okay, what that means is 4 to the negative 1st times 10 to the negative 1 times negative 4 is 4. This is kind of a squirrely one to do. You know that you can turn this into a positive exponent by putting it in the denominator, right? So this is the same thing, times 10 to the 4th. Anything to the power of 1 is itself. So really this is 1/4. 1/4 is 0.25 times 10 to the 4th. That's kind of a racket. Sorry, the other questions I don't think are nearly that complicated. You can handle it. You're smart. So change this to the correct form. I just increased, so now I decrease. And then write this in standard form. I moved my decimal, that was here, 3 place values to the right because this is a positive exponent. Whoops, you can't see what I'm doing. So again, check yourself with a calculator if you need. Most of these word problems at the bottom are really interesting factoids, but basically they just want you to write these really large, really small numbers using scientific notation. I don't know that you are really doing any operations with them except for maybe, 32 and 35. Yep, I think that's it. Maybe 34 too. That's a really interesting question. All right, well, I hope that's helpful. If you are still stuck, I sure do want to help you. So please email me at drones, she drones on and on, at d231.rochelle.net. Wouldn't give you my email address if I didn't want you to bug me, because you're not actually bugging me. All right, hope that helps. See you guys later.